So the constant keyword in C++ essentially allows us to create variables that cannot be changed, right? Whose value cannot essentially be changed, right? So some of these examples of those values is simply values like the value of pi, right? The value of pi wouldn't change regardless of whatever you're doing in the program, right? So how we can go about creating such variables, we can go ahead and say const, which is prefixing the data type with the word const, right? Very important, right? And then we can just go ahead and write pi. It is a good habit to capitalize your constant variables because so that you can just essentially distinguish them from the normal variables, right? So let's just go ahead and give it the value 13.4, right? So that's essentially how we can create a constant variable, right? Meaning the value of pi cannot be changed throughout this program, right? So let's just go ahead and see what happens when we try and change that value of pi, right? So we're going to go ahead and change it to, suppose we want to change it to 3.5. Right, let us see the error that we get, right? So when you hover over this, right, it shows that we cannot essentially change the value of pi, right? Because it is a constant variable, right? So what is important to note, it is that whenever we're passing in parameters, like we mentioned in our functions video, right? As much as this is a constant variable and we say that it does not change, but does not change within the scope of this function, right? This is a normal variable. Remember, we're going to talk about reference variables and pointer variables, but this only stays constant within the scope of this function, right? So suppose we created a function, right, just to print the value of pi, just going to say print, and it takes in the input pi. So what we can do within the scope of this this new function is that, remember, what happens now is that we actually make a copy of this value, right? We're no longer working on this actual value, right? We're making a copy, and that is why in the scope of this function we can go ahead and actually modify it, right? Let's just go ahead and modify and add 1, right? And then print that value. Right, what I want to do is actually also print the value after the call, right? Just to show you that nothing really changes, right? So I'm going to make the call and then print the value. So let's just go ahead and compile this. Right, as we can see that the value within that scope of that variable can be changed, but no change is really made to the pi value, right? So that's how we can create constant variables, right, with normal variables, right? So let us see how we can actually use it with reference variables, right? So the constant keyword, what we're going to change is essentially our parameter and say that it is a constant, it is a constant variable, right? So what is important is that what we're passing in is essentially a reference, right, to this exact variable, right? And that is why you can see that now this thing highlights and says that we cannot actually modify this value. We can only read this value because we're actually passing in the reference to the exact variable, right? Remember how the reference variables actually make changes to the original variable, right? Opposed to just making a copy, right? And that is the case that we are seeing now, that when you try and modify this value, it does not actually allow us to modify, because what? This is a constant variable, right? It's just that now what we have changed is that we're actually passing it with the reference, meaning the actual reference to the actual memory, right? So we're not just making a copy, right? So that's something to just be aware of, right? We don't even need to even compile in this case, because we can see that it's already saying that we do not need, we cannot modify this value. We can still print it, right? There's no problem with printing it, because in this case what we are doing is just making it a read-only variable, right? So there's nothing wrong with that, right? So that's essentially how we can use it with reference variables, right? So let's just go ahead and remove this and compile to show that it does work, right? As we can see that we can just print the value, no modification. We're not allowed to make any modification, right? So let us go to the more interesting part, which is how the const keyword works with pointer variables, right? So all right, so let's just see how the const keyword works with pointer variables, right? So what we need to be careful of is where we place this const keyword, right? Or this const word, right? So when we place the const word in front of the data type, right, when we're dealing with pointer variables, right, essentially what it says that the the value, right, the value that's going to be stored on the heap memory, right? Remember, with pointers, we're working with the heap memory. The value that's going to be stored on the heap memory is essentially going to be a constant value, right? For example, 3.14, like the pi value, right? It's going to be a constant variable, right? But, right, the pointer can actually change. So the value cannot be changed, but the pointer can actually be changed to point somewhere else. Let's just see how that works, right? So I'm just going to convert this into a pointer variable. What we need to do is essentially allocate that memory on the heap, and then we just need to change the parameter, right? So what we need to be aware of is that, remember we said the value that is stored on the heap memory cannot be changed, but our pointer can actually be changed, right? So let's just go ahead and try something, right? So let's try and modify the value that we said it's a constant, right? So let's just go ahead and say plus 10. Right, as we can see already, let me say pi, but as we can see already that this value cannot be changed, right? So essentially it's saying that to us that this value of pi cannot be changed since it is a constant on the heap memory, right? So what we can do is essentially print it, right? That is not the problem. We can go ahead and print it. Let's go ahead and print it over here, right? And that wouldn't be a problem. But another thing that we can do, remember we said that the variable is a constant, but not the pointer, right? The pointer can change and point somewhere else, right? So that is essentially what we're going to do. We want to point the pointer somewhere else. Let's just go ahead and do this. We're allocating new heap memory, right? And then we're just going to console log the new value, right? Right, so we're just going to print it, the value of pi, before we actually change our pointer to point to a new address, which is the value of 10, right? And then we're just going to print the value, right? So let's just go ahead and do that. Right, as we can see that at first it's pointing to 3.4, and then we just changed its address, right? So that's essentially how that keyword works. The other way to do this is essentially put the keyword constant after, right? It's going to be after the data type, right? So what changes with this is that the keyword, when it's after the data type, essentially saying that the variable that is stored on the heap memory can be changed, right? Very important, can be changed, but the pointer cannot be changed. Right? It's just vice versa, or the opposite of what we did previously, right? So the pointer cannot change. It's going to stick to that memory location, but the variable can be modified. The variable on that heap memory can essentially be modified. So let's just go ahead and update our parameter. And as soon as we do that, we can already see that an indication that says that we cannot actually modify, we cannot actually change where our pointer is actually pointing. Right, so we can see that we do not have the ability to change where the pointer is pointing. So this would be invalid when we compile, right? So, but what we can do is essentially modify the value, right? Let's just go ahead and modify the value, right? So you see that it does allow us to modify the value. What I want to do is essentially print it before and print it after I modify it, right? So let's just go ahead and compile this. Right, as we can see that before we changed the value, it was 3.14, and then after we changed it, right, it was 10, right? And although this may look familiar, rather similar, right, they're not necessarily the same because of how we actually changed that value, right? So in the first one, we actually moved the pointer. In this one, we actually changed the value, right? So what happens if we have the const before and the const after, right? So you can already tell that what is going to happen is that the variable is going to be a constant and the pointer is going to be a constant, right? So let's just go ahead and update our parameter, right? So essentially this is the safest variable there is. It cannot be changed and its pointer cannot be moved, right? So as we can see already, when we try and modify this, it does not allow us, right? Even if we tried, let's go ahead and try and change the location of the pointer. Right, as we can see that this value cannot be modified, so we cannot change the pointer address, nor can we change the value at that specific place, right? So that's essentially how we can use the const word in the pointer variables, right? So all in all, that's essentially how we can use the const keyword in creating different types of variables. right? So if you really enjoyed this episode, you can go ahead and leave a like, comment, any suggestions, and subscribe if you don't want to miss any new releases. Otherwise, cheers.